Today we are gonna teach you about more about Simulink. So first we'll talk about data type conversion. This is another block. You can find it in common use block, data type conversion. So what it does, you can see if you double click on it, you have list to choose from. Output data type. So let me get a display out here. Display. So if you double click on the data type conversion, you can see you have a lot of different output data type that you can choose from. Most frequently, you would use double. So what is double? Means it's a double precision floating number. And the other ones, like this, int 8, means I think it means 8-bit integer. And uint means unsigned integer, which means you cannot have negative number in this. And finally, you have this boolean, which means the data only consists of 1 or 0, which is just like what we had the logical array, which we learned in MATLAB. So like this. So basically all the default numbers should be double. So if you let it convert to double and let it run, nothing will happen. It's still the same value. But if you choose integer, it will just automatically cancel out those number behind that is smaller than 1. And like 0.8, it won't be 103. If it won't give you +1 if it's higher than 5. It just cancels out anything that's behind. And for Boolean, any non-zero number, it will go with 1. Even if you do like this, 0.1, it will show 1, which means true. Only 0, and it will stay with 0, which means false. So why do we need this? This data type conversion, it won't matter if you are doing a really small project. But if you are doing a big project, it will means a lot. because it will affect your calculation speed. Like if you are sure that you're like you have a variable called a, and you are sure that a will only be integers, then you wouldn't care what's behind. So if you automatically select it to integers, the memory it takes will only be like this, int integer 8, and it will only be consist of 8 bits. But if you do it with a double precision floating point, which is a default option, and you use it to store your integer, it will still take, I think it's 64 bits, which is 8 times more. It takes up 8 times more space in your memory. So it will affect a lot to your calculating speed. But one thing to notice though, like if you use integer, and let's say you have 3, and let me add something between. Let me add another number and a math operation, divide. And let me divide it by 2. So 3, now it's a double. So in memory storage, it will be 3.00000. But now I convert it to integer, so it will be only stored as 3. But now I divide it by 2, which comes out should be 1.5. So it automatically changes back to double. The number now is not integer anymore, because 3 can so yeah, and these are all the data type that you can use with this block. And you can check out what all these restrictions, what are all the restrictions about all these data types on the net. So let's go in another topic. Logical operation. So what is logical operation? Remember, as we talked about, there's a Boolean type of data in here, which means true or false. So we can have true or false statements inside Simulink. For logical operation, You can find it here. Logical operator. Let me give it two constant. Bruh. Two constant. And then a display. So the logical operator basically is and, or, and all these other. And you can change by double clicking it. You can change the number of input ports. Now it's set to 2, which means you can have two inputs. And of course you can have 3, have 4, have 5 inputs. Depends on what you need to use, how many you need to use. So for AND, using AND, it will return true if all inputs are true. So now, this is true. The first input is true, second input is also true. So now it will output as true. But if any one of these is false, then it will give you a false. As for OR, if one of them is true, then it will return true. It will only return false if both of them are false. And an AND. Returns true if one of them is false. And so return false if both of them are true. And the rest you can just take a look at for yourself. And then we take a look at relational operator. So relational operator is just like the thing you use in a if. It's like a if condition. So this 6 on the top is called 2 input. Let me take a look. Yeah, 2 input mode. And aside from that, you have a 1 input mode. So what are the difference? For 2 input mode, like this, smaller or equal. So the first one is the number if you want to check, and the second input will be your condition. So like if you put it like this, then it means you want to check if 1 is smaller or equal to 2, which is true. So it will return 1. Right? If it's like this, is 5 smaller or equal to 2? No. So it returns false, which is 0. And the rest is just like when you use the if. This means check if it's equal and check if it's not equal. And check if it's smaller or equal, greater or equal, greater. And then now we have the last three type. These three are called one input mode because you would only have one input. Like this, if you select this is INF, it only have one input, as you can see. So what is this? This is to check if the number of inputs is infinite. Infinite. What am I saying? if it is infinite or not. So for 5, is this infinite? It's not. So display is 0. So if today I put it like if I do 5 divided by 0, then it should be an infinite number. Because any number divided by 0 is infinite. So it displays true to you. And also you have the option to check if it's finite. And this is NaN means it want to check if it's a number. If it's a number, then it will return as true, which infinite isn't a number. So if you have like words, if you have the data type like string or something, then it will return as 0 because it is not a number. If you like do it like this, it's not a number. Hang on. Did I got something wrong? Oh. So sorry, NaN is not about, it's not checking if it's a number or not. Is NaN means if there's a data inside. Like if it's 0, it is still a data. So it is always false if you have any input out here. But if it's like empty, then it will return as true. So let's get to the main topic today, the integrator. Remember last week we have do this. This is the Simulink model for this ODE. But why is it formed like this? So in Simulink, what is actually x equals to 5? If we consider x is your output, how to model that actually model that in Simulink? So you need a display and an input. Connect it together and set it to 5. So this is x, which is your output right here. And you give it equals to 5. So you have 5 output as your x. This is what x equals to 5 means in, I should say it this way. So this model means x equals to 5. So what do we do if we have it double dot, x double dot equals to 5? We would double integrate it on both sides. So on the left hand side it becomes x, and the right side it will be double integral 5. So which means 5 now not going straight to your output. You need to integrate it. So you need to put 2 integrator. And connect it through. So now this is the model for this 5 integral and another integral now equals to your output x. So in the same logic, back to our original ODE, we would do double integral on both sides, and x double dot double integral becomes x, and then you put everything to the other side. So now you have your output on your left hand side, x equals to 5 double integral 5 minus double integral x and minus double integral 2 x dot. So how do we actually model this? As you can see, we have three things here. So we need to use a sum. And make it three inputs. And then connect the first one. And then connect all this together first. So previously we look it from left to right. And now you can, but what if you look it from right to left? The integrator becomes differentiate. Differentiate. So what is the data if you pull a line out here? What is the data right here? It's x. What if you put it here? If you draw a line from here, it means this number coming out is x dot. And this is x double dot. So you can see, if we put the double integral to the outside together, you can see it's double integral 5 minus x minus 2x dot. So you model it right here. 5 minus x. So this is the x. And now you need a gain. And flip it. And set it to -1. So plus negative x, and then plus negative 2x dot. This data is x dot. So plus negative 2x dot. And then everything integral 2 times. So this is why we had a Simulink model like this. Oh, because it's a dynamic problem, so we actually can't use it as constant. Almost forget that. We need to use a gain and a step. Because it's time dependent and it's not time independent. if you use constant 5, it is time independent. It does not have anything to do with time. If you use step, it is when time is 0, the value is 0. When you click start, then the 0 value becomes 1. And what you want is to set this value to 5. So you have a gain of 5. So now you complete the Simulink model. And you can look at it via scope. To actually see what it responded to time. This is how you create an ODE to your in Simulink. And then we'll talk about the last thing, which is saturation. You have actually 2 ways to set a saturation. One type is in the integrator. You have this limit output. So as you can see from the scope, we have this value from 0 all the way to like almost 5. So if you do the upper limit, like set it to 4 and let it run. When the value is actually greater than 4, then you will just keep return the value of before, because it means the greatest number you want is 4. You don't want any number to be higher than 4. Another way to do it is you can find it in commonly used block, saturation. And you put it here. You put it between the line. So right here, you can see the same setup. You have the upper limit and the lower limit. If you like set it to 1 to 4 and let it run. Now, if the value is smaller than 1, it will show you 1. And if the value is greater than 4, it will only show you 4. This is useful if you want to get rid of some extreme values. Yeah, today's homework. Today's class is this is all for today's class. And this is your homework. I have an ODE for you. 3x double dot minus 2x dot plus x equals to 0.2. And I want you to make a Simulink model of it. Homework due is next Tuesday, 11:59 p.m. And I want something like this. It's actually just change of a number, if you actually know how to do it. After you've done it, you can save it. Save it as a Simulink model .slx file with your student ID. Student ID underscore TA underscore homework 8 .slx. Yeah, that's it for today's class.